Hello everyone, welcome back to the channel. In today's episode, we are going to break down factorization in the easiest way possible. So, let's understand what is factorization. So, factorization is breaking down or splitting a number to its lowest factor possible. Okay? In the previous episodes, we have seen about prime numbers. And what were the prime numbers? Prime numbers were those numbers which has exactly two distinct factors. And what were they? One and the number itself. So we can say that 2 was a prime number, or 2 is a prime number which has two distinct factors, 1 and the number itself. So we can see here that the prime numbers cannot be split any further. So the factors are 1 and 2, 1 and 3, 1 and 5, 1 and 7. At the same time, we saw another number type called composite numbers, which has more than two distinct factors, right? So 4 was a composite number. So the factor of 4 was 1, 2 and 4. So if we break down 4 into its lowest factor possible, it will be written as 2 into 2. 6 can be written as 2 into 3. 8 can be written as 2 into 2 into 2. 9 can be written as 3 into 3. We see that these numbers cannot be split any further, right? As we have already broken them down to the lowest factor possible, which are nothing but the prime factors. So 2, 3, these are the prime numbers, right? Let's take one example, 12. So 12 can be broken down into 4 into 3, right? Now 4 can be further broken down into 2 into 2 into 3. So you can write 2 as 2 to the power 2 into 3 to the power 1, right? Similarly, take 36. Okay, so 36 can be written as 4 into 9, right? Now 4 can be written as 2 square and 9 can be written as 3 square. We cannot break it further, right? Because none of the factors here are composite numbers. So we can also say that breaking down or splitting any number in the prime number format is called factorization, right? Once again, I'm repeating. Breaking down or splitting a number to its lowest factor possible is called factorization. Similarly, we can say that breaking down or splitting a number in its prime number format is called factorization. Okay, now let's say we have a given number that needs to be factorized. Take example 60. So 60 can be written as 6 into 10. Now 6 can be written as 2 into 3 and 10 can be written as 2 into 5. So 60 can be written as 2 to the power 2 into 3 to the power 1 into 5 to the power 1. So this is the factorized form for 60. This has been broken down to the prime number format and it cannot be broken down any further. Let us take another example. 864. Now we know that since the number is big, we will take the help of divisibility rule. Now we can see that the number is divisible by 2. Last two digits are divisible by 4, so the number is divisible by 4. And last three digits is divisible by 8, so the number is divisible by 8. So to factorize, we'll take the help of divisibility rule, and dividing by 8, we can write as 8 into 108. Right? Now 8 can be written as 2 to the power 3 and 108. Last two digits is divisible by 4. So dividing it by 4, we get 4 into 27. Now 2 to the power 3 and 4 can be written as 2 to the power 2 and 27 can be written as 3 to the power 3. Hence we can write it as 2 to the power 5 into 3 to the power 3. Right? Now the question arises that why do we factorize? So we do factorization of numbers because by factorizing we can say a lot of properties of a number. Let us take an example. The given number is, say, n is the given number and the value of n is 12 to the power 2 into 24 into 30 into 40. Say, this is the given number. Now, with the help of factorization, we can tell a lot of properties of this number. So let's first simplify this to the simplest form possible. So 12 we can write as 4 into 3 to the power 2. 24 can be written as 8 into 3. So 8 can be written as 2 to the power 3 into 3 to the power 1. Now 30 can be written as 3 into 10, and so 10 can be written as 2 into 5. Now 40 can be written as 4 into 10, and 4 can be written as 2 square, and 10 can be written as 2 into 5. Right? Now we will break it further. 4 can be written as 2 square. This is 3. This is square. So now let's simplify. 2 to the power 3. Here is 1, 4. Here is 2, 6. And here is 1, 7. So we can write 2 to the power 7. Now 3, 1 here, 2. So we can write 2. And we have 2 5s. So we can write as 5 to the power 2. Opening the bracket, we get 2 to the power 4 and plus 7. So we get 2 to the power 11 into 3 to the power 2 and 3 to the power 2. So we get 3 to the power 4 into 5 to the power 2. Now this is the simplified form of n, right? Now let us see what the properties of n. Okay. So from here we can say that n is an even number. And why do we say so? Because n has a multiple of 2. And we know that any number which has a multiple of 2 will always be even. Second property, we can say that the given number is divisible by 2, 3, 4. So divisible by 2, 3, 5, 2 to the power 2, that is 4, 3 to the power 2, that is 9, 5 to the power 2, that is 25. Now 2 to the power 3, that is 8, 3 to the power 3, that is 27, and so on. That is, we can find the factors of the number by using factorization, right? We can also say that by seeing the factorization of the number that n is not divisible by n is not divisible by 7, 11, 13, 17, and so on. Now we can say that this number is neither a perfect square nor a perfect cube. Square nor a perfect cube. And why do we say so? Because for a number to be perfect square, the power of the number should be even. And for a number to be perfect cube, the power of the number should be multiple of 3. And it does not fulfill any of the two criteria. So we can say that the given number is neither a perfect square nor a perfect cube. We can also say that it will have exactly 2 trailing zeros. And how do we say so? We can see we have 2 5s and 11 2s. Now with the help of 2 5 and 11 2, we can make a maximum of 2 pairs of 5 and 2. So 2 pairs of 5 and 2 will bring us 2 zeros, right? Okay, let us see few applications. So the question is, by which list number, by which list number should 1440 be divided so that the quotient is an odd number. So how do we find it? Let's factorize it first. Sorry. So we have 1440, right? So let's split it. So we know that 144 can be split into 12 into 12 multiplied by 10, right? So this can be further split down 4 into 3. So 4 we can write as 2 to the power 2 into 3. Similarly, 2 to the power 2 into 3, and 10 can be written as 2 into 5, right? Hence, we can write it as 2 to the power 2 to the power 2 and 1. So 2 to the power 5 into 3 to the power 2 into 5 to the power 1. Now this is factorized. Now the question asked is, by which least number should 140 be divided so the quotient is an odd number? Okay. We know that for a number to be even, we need one of the factor as 2. So we know that, say, even, or in other word we can say that even number equals to 2 into anything. Okay, so 2 into anything will give us an even number. So for this number to be odd, it should not have any factor of 2, right? So to get the quotient as an odd number, we should not have any factor of 2, because even if there is a single factor of 2, 2 multiplied by anything gives an even number. So we have to eliminate all the factors of 2. So if you have to eliminate all the factors of 2, we will divide this number by 2 to the power 5, which will give us 3 square and 5 to the power 1 as quotient. Now this number will be odd as we don't have any factor of 2 here. Hence, the answer is 2 to the power 5. Okay. Okay. Let us see another concept. Okay. Or another question. Say which least perfect square will divide 400? The question is which least perfect square will divide 400. So here let us factorize 400. So 400 can be written as 4 into 100. So 2 square, and 10, 100 can be written as 10 into 10, which we can write as 2 into 5 into 2 into 5, as 400 can be written as 2 to the power 4 into 5 to the power 2. And the question asks which least perfect square will divide 400. People will immediately answer saying this, that 2 to the power 2, which is wrong. Why? Because the least perfect square is 1 and 400 is perfectly divisible by 1. So the answer is the least perfect square is 1. Now if the question is flipped, which greatest perfect square will divide 400? Now we know that we have seen the factorization of 400, 2 to the power 4 and 5 to the power 2. And we see that the power are multiple of 2, right? Now, and we know that for a number to be perfect square, the power of the prime number should be even, right? So the number is 400 itself. So if greatest power is largest perfect square is asked, then it will be 400. 400 is a perfect square of 20, right? So we can also, from this, we can derive that perfect square equals to prime number to the power even into prime number to the power even, and so on, right? Let's take example 4 to the power 3. Is it a perfect square? So we know that 4 is a composite number. 4 is not a prime number. So first thing we will do is we will break this into simplest form possible. So 4 can be written as 2 to the power 2 and to the power 3, which makes it 2 to the power 6. Now we have a prime number to the power even. Hence this is a perfect square. Now perfect cube. So for a number to be perfect cube, it should be prime number to the power multiple of 3 into another prime number to the power multiple of 3, another prime number and to the power multiple of 3, and so on, right? So we can say that 2 cube is a perfect cube, okay, because it is having a multiple of 3 as, I mean, in the power, okay. 3 to the power 6 is perfect cube, 5 to the power 9 is perfect cube. We can say that 5 to the power 9 into 7 to the power 12 is perfect cube, because both 5 and 7 are prime number, and the powers for both the prime number are in multiples of 3, okay. Okay, let us see few questions. So here the given question is, tell me a number which is both perfect square as well as a perfect cube, right? So we know for a number to be perfect square, the power of the prime numbers has to be even, and for a number to be perfect cube, the power of the prime numbers should be in multiple of 3. So we can say that prime number to the power multiple of 6, 6 into prime number to the power multiple of 6, and so on, will be both perfect square as well as perfect cube, because to be both perfect square as well as perfect cube, the number has to be even as well as multiple of 3, which is possible when the prime number is, or say the power of the prime number is multiple of both 2 and 3, and to be multiple of both 2 and 3, it has to be multiple of 6. Hence, for a number to be both perfect square and as well as a perfect cube, it should be, the prime number should be multiple of, I mean, the power of the prime number should be in multiples of 6. Okay. Similarly, it said, tell me a number which is both a perfect square as well as the perfect fifth power. Now we know that for a number to be perfect square, it has to be, the power of the prime number should be even, and for the number to be perfect fifth power, the power of the prime number should be in multiples of 5. So multiples of 5, now 5 is not an even number. So just putting the number as multiple of 5 will not give us a perfect square. So that number has to be even as well. So we can say that to make it both perfect square as well as perfect fifth power, it has to be prime number to the power of multiple of 10 into another prime number to the power of multiple of 10, and so on. So this is basically the concept. Okay. So whatever is asked, you have to see what is common between them. You have to take the common, and whichever power is, you know, fulfilling the common criteria, the multiples of that power on the prime number will fulfill the given scenario. Let us take one example. The question here is, which greatest perfect cube will divide 864? Here it says that which perfect cube will divide 864. So 864, we know that we had already taken example of 864 earlier also. So I'll break it down. 864 can be broken down into 8 into 100 8, and we can write it as 2 to the power 5 into 3 to the power 3. Now it is asked which perfect cube, which greatest perfect cube will divide 864. Okay, the greatest perfect cube is asked. Now 2 to the power 5 is not a perfect cube, right? We know that 2 to the power 5 is not a perfect cube. And we cannot take anything greater than 2 to the power 5. Okay, so we have to take something smaller. So the greatest perfect cube less than 2 to the power 5 is 2 to the power 3, right? And from this factor 3 to the power 3, this is a perfect cube. So the greatest perfect cube that will divide 864 is 2 to the power 3 into 3 to the power 3. So 2 to the power 3 into 3 to the power 3 becomes our answer. Okay, let us see a few more questions. So by which least natural number should 720 be multiplied so that the resultant is a cube as well as a square? Okay, so the number given is 720. So let's factorize it first. So 720 can be written as 72 into 10. 72 can be written as 8 into 9, and 10 can be written as 2 into 5. Now 8 can be written as 2 to the power 3, 9 can be written as 3 to the power 2, and 2 into 5. So we have 2 to the power 4 into 3 square into 5 to the power 1. Now by which least natural number this number should be multiplied so that we get a cube as well as a square, right? Now we know that to make it a cube and a square, the power needs to be multiple of 6, right? So what can be added to make its power, or we can say that what can be added to make the power of the numbers multiple of 6? So in this case we have 2 to the power 4. So if we multiply this by 2 to the power 2, we will get 2 to the power 6. Similarly, we have here 3 to the power 2. If we multiply it by 3 to the power 4, we will get 3 to the power 6. And we have 5 to the power 1. So if we multiply it by 5 to the power 5, we will get 5 to the power 6. Hence, we will get all the powers if we multiply the given number by this number as power of 6, as multiples of 6. The power will multiple of 6. Hence, this is the number by which if we multiply 720, we get the resultant both a perfect square as well as a perfect cube, right? Let's take another example. By which least natural number should this number be divided so that the resultant is an odd number as well as a perfect square? Now here the given number is 12 square into 18 into 25 into 15. Now 12 can be written as 4 into 3, which can be written as 2 square into 3 square. 18 can be written as 9 into 2, so we can write as 2 into 3 square. 25 can be written as 5 square, and 15 can be written as 3 into 5. Breaking it down, simplifying it, we get 2 to the power 2 into 2 4 and 1 here 5, okay, into 3 to the power 5 into 5 to the power 3, okay. Now the question asks is, by which least number should this number be divided so that the resultant is an odd number as well as a perfect square? Now the number to be an odd number as well as a perfect square, okay, to make the odd number you have to remove all the factors of 2, right? So to remove all the factors of 2, divide the number by 2 to the power 5. So this will remove all the factors of 2, making the number odd. Now to make it perfect square, the power of the remaining prime numbers should be even. Okay. Now we have 3 to the power 5. So if we remove 1 3, we will get 3 to the power 4, which is a perfect square, right? Hence we will divide it by 3 to the power 1. Similarly, for to make it a perfect square, we have to make the power as even. So we'll remove 1 5 as well. Hence, if we divide the given number by this, we will get the resultant as an odd number as well as a perfect square. Okay, let us see a few more uh, questions that can be solved through factorization. So the question is, find the number of trailing zeros in the product of the given number. Okay, so let's first simplify it. Given number is 250 to the power 5 into 12 to the power 3 into 18 to the power 2. So we can write it as 125 into 2 to the power 5. Now 4 into 3, 4 can be written as 2 to the power 2 into 3 to the power 3. 18 can be written as 9 into 2. So 2 into 9 can be written as 3 to the power 2 to the power 2. Right? Now 125 can be written as 5 to the power 3 into 2 to the whole power 5. Now this we get 2 to the power 6 into 3 to the power 3 into 2 to the power 2 into 3 to the power 4. Okay. Okay. So 5 to the power 15 into 2 to the power 5 into 2 to the power 6 into 3 to the power 3 into 2 to the power 2 into 3 to the power 4. So what we get? 2 to the power 5, 6, 11, 13. 3 to the power 7 and 5 to the power 15. Okay. Now we have 13 twos and 15 5. So how many pairs of 2 into 5 can we get from this? So we will always get whatever is the least value of the 2s and 5 that we are getting. So if we have 13 twos and 15 fives, the maximum number of pair of 2 and 5 we can make is 13. So we can make 13 pairs of 2 into 5. Hence the number of trailing zeros we will get is 13. So 13 is the answer. Now let's see another question. Which least perfect square will be divided by 960? So it says that which least perfect square will be divided by 960. So we don't know what is the least perfect square. So we can write it as least perfect square divided by 960. Okay. So first let's factorize 960. So 960 can be factorized as 96 into 10. Now 96 can be factorized as 2 into 48. 10 can be written as 2 into 5. Now 48 can be written as 96 can be written as 2 into 48 and 10 can be written as 2 into 5. Now simplifying it further, so 2 into 48 can be written as 4 into 12. So 4 we can write as 2 to the power 2 and 12 we can write as again 4 into 3, which is 2 to the power 2 into 3, and we already have 2 into 5. So this we can write as 2 to the power 6, simplifying 3 to the power 1 and 5 to the power 1. So the question asked is which least perfect square will be divisible. Now which least perfect square will be divisible? So the number has to be perfect square. That means the power must be even. Okay. So we can take the even powers of the factorized even numbers of 960. So 2 to the power 6 is even. So we can keep it as it is, 2 to the power 6. Now 3 to the power 1 is not even. So which is the least perfect square that 3 to the power 1 can divide? So that is 3 to the power 2. And which is the least perfect square with that 5 to the power 1 can divide is 5 to the power 2. So 2 to the power 6 into 3 to the power 2 into 5 to the power 2 will become our answer. This is the least perfect square that will be divided by 960. Now if the same question is reversed and asked to find the least perfect cube that will be divided by 960. Okay, in this case what will happen? We know that for the number to be least perfect cube, it has to be multiple of 3 and to be divisible by 960. These it should have factor of 2, 3 and 5. So the least perfect cube will be, so we have 2 to the power 6 and 6 is multiple of 3, right? So 2 to the power 6 we can write. Now for 3 to the power 2, the least multiple is, that can be, you know, the least perfect cube that is divisible by 3 square is 3 to the power 3. Similarly for 5 it is 5 to the power 3. So this is becomes our least perfect cube that is divisible by 960. Okay, let's see some uh, more complex problems. So the question is find the sum of the digit of the least number n such that 2n is a square and 3n is a cube. So here it is asked is we have we have asked the sum of the digits of the least number n such that 2n is a square and 3n is a cube. So we can solve this question by hit and trial as well by assuming values, but right now let us focus on the concept. So we can write this number as n equals 2 to the power a into 3 to the power b. Why not power of 5 and 7? Because what is asked is least number, right? Least number is asked, and if we add power of 5 or higher value, it won't be the least number. So we have to get the least number, hence we are not taking the power of 5 and 7. Okay, now we know that n is in the form of 2 to the power a into 3 to the power b. It is also given that 2 into n is a perfect square. So we can write it 2 into 2 to the power a into 3 to the power b. If we club it, it becomes 2 to the power a plus 1 into 3 to the power b. And this is perfect square. You know, right? It is also given that 3 into n is a cube. So we can write it as 3 into 2 to the power a into 3 to the power b, which can be written as 2 to the power a into 3 to the power b plus 1. And this we know is cube, right? Now for 3n to be a perfect cube, a should be multiple of 3, right? So what are the possible values of a? Now we can write 3n to be a perfect cube. A should be multiple of 3. So the possible values of a are: a can be 0, a can be 3, a can be 6, a can be 9, a can be 12, and so on. And what are the possible values of b? So let us see here. If we put value of a here, okay, a is 0, we get 2 to the power 1. Now we get 2 to the power 1, which where the power is not an even. So it will not be a perfect square. So 0 is ruled out, right? Now let's take value of a as 3. 2 to the power 3. Yes, it's a cube. Now let us take here a as 3. So 2 to the power 3 plus 1. So it becomes 2 to the power 4. Here the power is even. So it is a perfect square. So fulfilling both the criteria. 2 to the power, here it's a perfect cube and here it's a perfect square, right? So we can assume the value of a as 3. Now the least number is asked. So we will not go any further. Okay. Now let us take value of b. Now 3 to the power b is a perfect square. So b can take value as 0, 2, 4, 6, and so on. Now let us take b as 0. So if b as 0, so this is fulfilling this criteria, but if we take b as 0, it gives 3 to the power 1. And here the power is not in the multiple, the power is not multiple of 3. So 0 is ruled out. Now let us take 2. 3 square is a perfect square, hence this fulfills the criteria. And here b is 2, so 2 plus 1 becomes 3. Now 3 to the power 3. So the power is multiple of 3, hence 2 fulfills the criteria, hence 2 can be taken. Since we need the least number, we will not go any further. Okay. Therefore, n can be written as 2 to the power a, and a is 3, into 3 to the power b, and b is 2, right? Which gives 8 into 9 equals 72. But this is not the answer, because the question is find the sum of the digits. Sum of the digits of the least number n. So sum of the digits is r. The sum of the digits is 7 plus 2, which is equal to 9. Hence 9 becomes the answer. Let us take the last question of the day. For how many integral values of a is the given number an integer? Okay, and the given number is 15 to the power a plus 3 into 28 to the power 8 minus a to the whole 35 to the power 2a minus 9. Now, how do we approach it? Let us factorize it first. Okay, so 15 can be written as 3 into 5, right? So we can write it as 3 into a plus 3 into 5 into a plus 3, and 28 can be written as 7 into 4. So 7 into 8 minus 1, sorry, 8 minus a, and 4 can be written as 2 to the power 2. Now you can write as 2 to the power 2 into 8 minus a. On top of, now 35 can be written as 7 into 5. So 7 into 2a minus 9 into 5 into 2a minus 9, right? Now from the rule of indices, okay, I have not taught indices, but I'll teach that in future episodes. But let's understand, when the power, uh, let's understand what we need right now. So 2 to the power 0 is always 1, or any number to the power 0 is 1. Okay. Similarly, if you take 2 square, we get 4, which is a positive number, okay, or an integer value. If you take 2 to the power minus 1, this can be written as 1 by 2. Similarly, if we take 2 to the power minus 2 into 3 to the power 2, this can be written as 9 by 4. Okay. Okay, now let's simplify it further. So we have in denominator 7 and 5. If we take them to numerator, okay, we will get 7, 9 minus 2a, okay, into 5, 9 minus 2a into 3a plus 3 into 5a plus 3 into 7, 8 minus a into 2, 16 minus 2a. Now this can be written as 2 to the power 16 minus 2a into 3 to the power a plus 3 into 5, 5 to the power 3, 12, this, okay. 12 minus a into 7 to the power 17, 17 minus 3a. Okay, so we can say that for the expression to be integer, this is the expression, for the expression to be integer, the power can either be 0 or greater than 0. It cannot be negative, otherwise it won't be an integer. Okay, we saw that if the power is negative, it becomes a fraction. So the power has to be 0 or greater than 0. Given number is an integer. So the power should be 0 or greater than 0. It cannot be negative. Okay. Because the given number is an integer. This is the main point. Given number is an integer. Okay. So we'll start with the simplest one. So a plus 3. Okay. We'll take 3 to the power a plus 3. And from here we know that a plus 3 should be greater than or equals to 0. This implies that a is greater than or equals to minus 3. So if we plot it in a line number, we get the value of a as, if you take it minus 3, a is greater than 3, right? Now let us take, we have taken 3, let us take the, we have taken 3, let us take to the power, 2 to the power 16 minus 2a. Okay, so we take 2 to the power 16 minus 2a. Now for this to be positive, okay, 16 minus 2a needs to be greater than equals to 0, right? This implies that a has to be greater than, this implies that a has to be less than or equals to 8, right? So if we take 8 here, a has to be less than 8 as well, right? Now let us take 5 to the power 12 minus a. So we can write 5 to the power 12 minus a. Now for this value to be 0 or greater than 0, this needs to fulfill this criteria. This implies that a should be less than equals to 12. Now we, from this equation we already know that a should be less than equals to 8. So a should be less than equals to 12 is ruled out. Now let us take 7 to the power 17 minus 3a, implies that 17 minus 3a should be greater than equals to 0, which implies that a should be less than equals to 5.66. Now here we saw a should be less than or equals to 3, but here we are saying a should be less than or equal to 5.66. So this is ruled out. Okay. So 5.66 will come somewhere, say here. So 8 should be less than this value. Okay. So from this we are getting that the value of a should be minus 3 to 5.66. So a can take any value from minus 3 to 5.66. Okay. But in the question, what is asked is for how many integral values of a. The integral values are only asked. Okay. So what are the integral values between minus 3 to 5.66? So the values are minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and 5. We cannot take above 6, and 5.66 is not an integer. Any value between minus 3 and minus 2 is not an integer. similarly. Okay. So how many integral values can A take? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Hence 9 is the answer. Thank you. Thank you for today.